Om Sri Sai Ram. Dear students, you are all ready to hear a lesson. Sri Sathya Sai, hearty welcome to Sri Sathya Sai Loka Seva Gurukulam. Chemistry class. Topic is on periodic classification of elements. You know what is meant by element, is it not? So in the previous class we have studied what is meant by matter. All the things what you see around us is called matter. It exists in the three states, namely solids, liquids and gases, and it consists of substances like elements, compounds and mixtures. What are elements? The simplest form of substances which cannot be broken up into simpler substances. What are compounds? And two or more elements combined together form a compound. Mixtures, again two or more elements not in a fixed ratio. If they are combined, they are called as mixtures. Here you can separate the contents in mixtures. In case of compounds, difficult because the ratio is fixed. When you say water is a compound, consists of hydrogen and oxygen, the fixed ratio. Is it not? Also you have seen what is meant by element contains atoms of only one type. If we say hydrogen, it has got atoms of hydrogen of only one type. And it is different from atoms of oxygen, different from atoms of nitrogen. So each element is different from the other. Hydrogen is a combustible gas, whereas oxygen is a supporter of combustion. Why does it happen? Because it is made up of different atoms, and so far it is found that 118 elements have been found. 94 are naturally occurring and the rest are prepared in the laboratory. So what do you mean naturally occurring? We may find in the atmosphere, is it not? For example, oxygen is in the atmosphere, nitrogen is in the atmosphere, like that, and some are prepared in the laboratory. For example, you have heard about radium. It prepared in the laboratory. It is a radioactive element. Polonium, actinium and so on. So most of them are naturally occurring. It may be in the gaseous state or in the solid state or liquid state. Okay. So that is the thing we already studied. And all the difference in the properties of elements are due to the different electronic configurations and structure of atoms. So when you say hydrogen is different from oxygen, it is due to the electronic configuration and how they are combined. So you should know what is the meaning of the word classification. I think I have visited some malls. What are malls? Very big shopping center, where you get all different kinds of materials, right? And when you go there, they write in the top that articles of daily use, for example, soap, if you take, they write the title there, bath soaps. So big line of bath soaps. Then say washing soaps, and then chocolates, biscuits, cold drinks, all different varieties. But what they do, they put in different boxes, different enclosures, and the top they write it. There is a kind of classification. Otherwise what happens? Suppose you go to a mall, it will be difficult to find out. Suppose you want a soap. You have to go on searching where the soap is. Now it is not like that. All provisions in one side, all clothes in another side, all eatables, fruits, juice, ice cream, and so on. That's what is called as classification. So grouping of things with the special properties. Even in a class also, for example, the PT master will come and select how many know cricket. Some of you raise your hands. How many know volleyball? Some others will raise. How many know badminton? Some others. How many know table tennis? Like that, they make different groups. Then it is easy to select the teams. So making teams is a kind of classification. I think you understood what I mean. So in your home also, when so many clothes are there, if everything is jungled, difficult to select one kind of clothes together. That is kind of a classification. I think you understood the meaning of that word, classification. And early attempts and regarding elements, there are different types of classification. One of them was called, earliest attempt was to classify elements into metals and non-metals. There are about around 90 metals are there, and the remaining are non-metals. But around 90 metals, difficult to make out the properties. Is it not? So the more and more scientific classification was needed. So scientists made several attempts to classify the elements according to their properties and obtain orderly arrangements. Even in our athletics, suppose you want to select a school team, what they do, 100-meter race or 200-meter race, like that, they select all, they call for all the boys or separately as girls to come and participate. Then they select, they give a rehearsal. In that they select some of the boys or some of the girls. So that is what is called orderly arrangement. Okay. And the first attempt was about metals and non-metals, but it did not give any comprehensive study of that. So what is the solution? The first one is called as Dobereiner's Triads. Note the spelling, Dobereiner, the first of S. Dobereiner's Triads. What means triads? Taking 3 at a time. That's why it is called as triads. So in 1817, J.W. Dobereiner, a German chemist, tried to arrange the elements with similar properties into groups. For example, chlorine, bromine, iodine. He made one group, identified some groups having 3 elements each. That's why it is called as triads. And it is based on a law. Just as your constitution, all the political parties or politics is based on constitution. There is a law behind it. How a governor must work, how ministers are working, and what are the limitations, what are the powers, what are the law for changing, how the elections made. All these are based on constitution. Is it not? So here also all the classification is based on what is called as a law. So what does the Dobereiner's law says? When elements are arranged in the increasing order of atomic masses. So what he did was, the elements known then is 19th century, 1817. He took all the elements and kept them in the increasing order of atomic masses. What is atomic mass? Atomic mass is sum total of the protons and neutrons. A equals Z plus N. You have studied a formula last class, in the last lesson. So A equals Z plus N, where A stands for atomic mass, Z stands for atomic number, N stands for number of neutrons. So when they are arranged in the increasing order of atomic masses, the atomic mass of the middle element, please note carefully. So what he did, what are the different elements available, he kept in the increasing order first. Then he took the mass, he found that the mass of the middle element was nearly equal to the arithmetic mean of the other two. I told about chlorine, bromine, iodine. See, atomic mass of chlorine is about 35.5 and this is about 127 approximately. So if you add those two, so 127 plus 36, it comes to about 127 plus 35.5, you make it as 36. That is approximately, I am telling. So it comes divided by 2, comes to about 81.5. So it is almost equal to this bromine. Bromine is 79 point something, or approximately it is 80. So what the law says, the mass of the first element and the third element, the average of the two. So this is the average, 163 by 2, that is about 81.5, is equal to the arithmetic mean of the other two elements. So this is arithmetic mean. That means you are add it and divide by 2. And properties were intermediate between those of other two elements. In properties also, see, all these are called as halogens. What do you mean halogens? Halo means salt, gene means producers. So they form salts. The salt of chlorine is called chloride. Salt of bromine is called bromide. Salt of iodine is called iodide. Of course, the calculation is not exact, approximate. Anyway, he found in those days that there is some similarity between the three, and hence the law is called law of triads, where elements like A, B, C are taken. So atomic mass, for example, A is of 20, atomic mass of C is 40. Come on, atomic mass of B is how much? 20 plus 40, how much it comes? 60. Average of the 60, that is divided by 2, comes to about 30. Can you make out? Okay. So what you must make? Average of the first and the last. Average of the first and the last will be taken. It will be approximately equal to the atomic mass of the middle one. Hence the law of triads. I think most of you understood now. Let us give one more example. So this is a photo of J.W. Dobereiner, a German scientist. In the 19th century, he lived and gave one contribution in the classification of elements. So here, for example, what are the different elements he took was, in the group A, nitrogen, phosphorus, arsenic. Here the average of these two is almost equal to the atomic mass of middle one. So for example, this is about 74 plus 14, so let's take 75, and I said it's almost equal to this. Here also the average of these two is almost equal to this. This one I just now told now. The sum of the two, that is average of that, is almost equal to 80. That is what is said as triads. And these are some example. Lithium, sodium, potassium, they are all metals. Similarly, chlorine, bromine, iodine, they are non-metals, but they are called halogens. Similarly, calcium, strontium, barium, they have got similarity and they have got the atomic masses like this. Okay, that is a one contribution he made. It is the very earliest contribution, and that is called as law of triads. Okay, now one more example we will see. In the triad consisting of lithium, atomic mass 6.9, almost equal to 7, sodium 23, potassium 39. The average of lithium and potassium, lithium is Li, potassium is K, and sodium is Na. So average of the lithium and potassium 6.9 plus 39 by 2, that is 45.9 by 2, that is almost equal to 23 atomic mass of sodium. This is what is called as Dobereiner's law of triads. Is it okay? So here you must note that this classification did not receive wide acceptance, since only a few elements could be arranged into triads. Even though there are more than 50 elements discovered at that time, he could not do it for all elements. That is called a limitation. So law of triads is not applicable to all the elements. What is the solution? See, that is what you say. For anything new, there should be some problem. Is it not? So that is there should be some question to be answered. So what is the next? Then came John Newland. He is an English scientist. In the year 1866, he discovered one more law, or he arranged it in another way. So what he did was, he discovered what is called a law of octaves. Octave means how much? Octave means 8. So he took groups of 8. What he did was, he arranged the then known elements in the increasing order of atomic masses. He started with the element having the lowest atomic mass, say for example hydrogen, and then he took arranged in the last one. 56 elements were known that time. Thorium, he first arranged all 1 to 56 in the increasing order of atomic masses. He found that every 8th element has properties similar to that of the first. And the most interesting thing you must note is that it is in similarity with the octaves of music. I think some of you may be knowing, you may be learning Indian classical music. He was very fond of music also. He found that this is in similarity with the swaras, what he calls swaras, sapta swaras. Here the first swara resembled with the eighth. That's why the word octaves was used. So what does the law says? Law says that the eighth element resembled with the first element when they arranged in the increasing order of atomic masses. For example, lithium and sodium. Lithium is atomic number 3. Sodium is atomic number 11. So 3 plus 8. So 8th element. So after is lithium is sodium. Were found to be the same, similar to beryllium and magnesium. They also resembled. That's what he found. It's a new way of representing the classification. So this is another way of classification. It is based on the octaves of the music. And this is a scientist that is Alexander Reina Newland, and who was a British chemist who told about the periodicity. You heard about pendulum, is it? Simple pendulum. You seen? You can try. Take a stand, iron stand, tie it with a thread. At the bottom you just tie it with a bob, metallic bob with a hook. So tie the thread to the hook, just pull it up to one side and leave it. What do you see? The bob goes to the other side and comes back. Again it go on oscillating. Is it not? So the same time, the time taken will be same. That is what is called as periodicity. So repeating at regular intervals. So for example, as you have the sa, re, ga, ma, pa, da, ni. After that what comes? Again sa comes. Sa, ni, da, pa, ma, ga, ri, sa. The sa comes again. That is the eighth swara. What do you call eighth? So these are the elements known then, and that is how we arrange this. He found that the property of hydrogen is almost equal to that of fluorine. It's almost equal to chlorine. Almost equal to bromine. Metals like lithium, sodium, potassium, copper, rubidium, they have got similarity. That's what he said. So again the eighth element, beryllium. Here onwards, if you count, the eighth element will be magnesium. Again after eighth element will be calcium. Then comes zinc. Then comes strontium. So they resemble each other. Just as we have musical notes, here also the elements have some similar properties. The first element resembles with the eighth with the 16th and so on. So these were the about 50 and odd elements known at that time. That was the second type of classification made. Now let us hear to a video. For example, the video is like this.
Re
Yes, sa, re, ga, ma, pa, da, ni, sa. So it starts with sa, ends with sa. Okay, that is the beauty of the music. Those who are good in music will definitely appreciate this, and that is how you study the classical music. Our country is very famous. Who is the father of classical music? Purandara Das. And Tyagaraja is the greatest name in the classical music. Is it not? So, those who know classical music, the basic thing what you study is this. There are two types in that, Arohana, Avarohana. Arohana means increasing, Avarohana means decreasing, right? So now there are some limitations. What are the limitations? Law of octaves. It was found that law of octaves was applicable only up to calcium. Later on it was not applicable. That was a limitation. And then second limitation was, it was assumed by Newland that only 56 elements existed in nature. But they discovered some more after that. So new elements were discovered after that 56. For that there is no chance, or the properties did not fit into the law of octaves. The repetition was not there. So up to 56 elements only he could do it. So the later discovery was not helpful, or this law could not be applied in that such cases. So the third disadvantage or limitation is, in order to fit into the elements into his table, Newland suggested two elements in the same slot, but also put some unlike elements under the same note. For example, cobalt and nickel, he put in the same slot because both are metals, and then these are placed in the same column as fluorine, chlorine and bromine. So same column, but the properties did not suit properly because, and one more thing was, these two are put in the same group. So he had some difficulty in that, for which he has no answer. Very different properties. Their property of chlorine, bromine, their halogens is quite different from that of cobalt and nickel. So he could not answer what to do with that. So what is that solution? So different properties have been placed far away from these elements. With the discovery of noble gases. What are noble gases? Gases like argon, neon, krypton, xenon, all these are called noble gases. Why are they called noble gases? They have sufficient number of electrons in the outermost orbital, or they are very least reactive. But Newland could not give place for them. Even though they resemble each other, his classification failed to answer this. So the law of octave became irrelevant. They are not at all relevant. So these are the limitations of Newland's law of octaves. But anyway, his contribution is to be appreciated because he has discovered his own way of classifying things. So as I just now told you, necessity is the mother of invention. For inventing anything new, because of the necessity. So when the elements after 56 were not able to set in properly, then came a scientist. He is a Russian scientist by name Mendeleev. He was very much worried. At that time there were about 63 elements. He had seen Dobereiner also, You had seen Newland's also classification of elements. He was very much worried what to do with this 63 elements known then. So one day he got an intuition, sudden flash, that these elements to be grouped in what are called as groups and columns. So some flash came to his mind. That's what scientists enjoy. Even you might have heard about Archimedes, was a scientist, was given to find out the amount of copper in the golden, there was a king in Italy who had a crown of gold, but he wanted to find out the quantity of copper in it. So he was given, all the scientists were called and to find a method of finding the other elements present in the crown. So all the scientists started thinking on that. Even Archimedes also went to a pond, swimming pool. He made that crown to dip into the water, and suddenly he got a intuition, a sudden flash of thoughts. Then he started shouting, and he went in the streets without dress properly. Went on shouting, Eureka, Eureka, Eureka. Eureka means I have found out, I have found out. What do you mean by that? What did he found out? He found out that the density, relative density, the density of copper and is different from the density of gold. And he used the property what is called relative density and so on, which you study in later classes. So similarly, Mendeleev also got a flash of arranging these elements. 63 elements were known at that time and their compounds. On arranging the elements in their increasing order of atomic masses, he observed that elements with similar properties occur periodically. On this basis, Mendeleev formulated a periodic law. So as I told a few minutes back, all these periodic table is based on a law. And the law says properties of elements and their compounds are the periodic functions of their atomic masses. He also arranged the elements in the form of increasing atomic masses, increasing order of atomic masses. He said that the properties also are the periodic functions, means they change in regular intervals, as we have just now discussed, like chlorine, bromine, iodine. Similarly, he thought of the inert gases like argon, neon, krypton, etc., etc. So they are all repeat at regular intervals. That is what he said. So that is why his table, Mendeleev's periodic table, is based on the periodic law. Let us see in the next class as how this is made. Okay. Before we close, we will see some of the homework assignment. The first question is, what was the limitations of Dobereiner's classification? Second question, what were the limitations of Newland's law of octaves? Third one, did Dobereiner's triads also exist in the columns of Newland's octaves? Compare and find out. Okay, come prepared with that. And fourth one, a simple problem. Elements A, B and C constitute Dobereiner's triad. Atomic mass of A is 20. Atomic mass of C is 40. What is predict the atomic mass of B? So three elements A, B or C are given. Predict the atomic mass of B. Okay, come prepared Wish you all best of luck. Thank you.